Hello everyone and welcome to my YouTube channel. My name is Claire, and in this video I'll be explaining to you what is urea cycle, what is its purpose, and why do we need to know it. Okay, so in the first place, one thing which I'd like to mention before getting into this topic is amino acids. Okay, so we know that amino acids are the building blocks of proteins. So the thing is, what does the sentence actually mean, building blocks of proteins? I bet you hear it a lot, but I like to think of it in this manner. If you have a house, okay, this house had to be built from scratch. A lot of people made a lot of effort to make this house, all right? So this house was made of bricks, and these bricks were held together by cement. This house was then plastered. After it was plastered, it was painted. We added a few window panes, some windows, and finally we call it a house. Amino acids are exactly the same way, okay? So I'd like you to think of amino acids as literally that, or as the blocks that you use to build a house. The only thing is, in this case, the house we are building is a protein. So you and I are made of protein. So human beings are made of proteins, whether men, whether women. The only thing that affects the display of these proteins is how we arrange them in the DNA, in the number of chromosomes, and a number of other factors. So biochemistry explains how amino acids will make a cow, how amino acids will make a chicken, how amino acids will make a human being. But it's not one topic that will explain. This conversation is a number of topics. So I'd like you to think of amino acids. We've taken these amino acids, we've put them together. We've either made a human being, we've made a cow, or we have made a chicken. Now that we have established this information, we can now dive a little bit deeper as to why we've spent a couple of minutes on this. So why was this necessary to know? So amino acids, okay, when we form a protein, we've got this ammonia, so it's still amide group in the general structure of an amino acid, okay? Now the thing is, this ammonia is toxic, okay? So to fully understand this, let's have a look at digestion. So what is digestion? Digestion is the breakdown of large insoluble food compounds into small water-soluble components so that they can be absorbed into the blood plasma. In certain organisms, these smaller substances are absorbed through the small intestine into the bloodstream. So when you have food on your plate, okay, just for clarity to establish what digestion actually is, the food on your plate, here we've got some steak, we have some mashed potatoes, and we've got some broccoli. The thing is, the cells in your body need to use this food, but they are too large in order for us to actually use them. So we need to make them small enough to break them all the way down to the smallest unit that we can, so that we can actually use these basically building blocks of what make up the proteins or the carbohydrates. So when we consume protein, we will break it down to amino acids. Now, the topic of digestion of proteins, I will discuss it in another topic. So, digestion of proteins shall begin in the stomach, okay? You will chew this steak, you will swallow it, and digestion of proteins will begin in the stomach. In the stomach, your protein will be broken down into a polypeptide and some amino acids. Finally, from the stomach, okay, we'll go down into the small intestine, and this will cause a release of enzymes from the pancreas to further break down this polypeptide into di and tripeptides, and finally all the way it will be broken down into amino acids. I will get into detail of how protein digestion takes place, but for this video in particular, it is about the urea cycle. So I'd like you to make the assumption that we have consumed a meal that is high in protein. Either you ate chicken, you ate soya chunks, you ate steak, and you have broken it down to amino acids, okay? So now that we have broken it down to amino acids, let's establish something really important again. So in the general structure of an amino acid, we've got ammonia, okay? So I'd like you to think of it in this manner. Ammonia is very, very toxic, okay? How toxic is ammonia? It is so toxic that it can actually cause central nervous system damage, okay? So ammonia, that's not to say that you cannot consume meat. In as much as there's ammonia and ammonia is toxic, that doesn't mean you cannot consume meat. Yes, it is dangerous to consume large amounts of meat, and we will get into that. So the thing is, I like to think of ammonia in some sense as a car without brakes. If a car has got brakes, in the event of an emergency, you can hit your brakes and avoid an accident. If a car does not have brakes, this is very, very dangerous and detrimental. So basically, in your general structure of an amino acid, because ammonia is attached to the alpha carbon, okay, this is what kind of gives it its brakes. But when ammonia is a free entity, when ammonia is just willy-nilly, it is very, very dangerous, okay? Think of it like ammonia not being attached to anything. Well, let me not say anything in particular, but let me say if ammonia is a free entity, it is dangerous. But if we attach ammonia to the alpha carbon on the general structure of an amino acid, it is not toxic. Our body does not want this ammonia, okay? What our body wants is the carbon skeleton of an amino acid. We will get into very, very big detail as to why our body only wants the carbon skeleton. For now, you just need to know ammonia is toxic, and when we consume a meal that's high in protein, our body wants to get rid of the ammonia and only take what it wants, which is the carbon skeleton, which is the carboxyl group, the alpha carbon, and the functional group, which can be a phenyl ring. And I will make a separate video on how to effectively draw the 20 amino acids, but I did make notes on it. But watch out for my next video where I'll show you how to effectively draw all the 20 amino acids. So we want to get rid of this ammonia, and certain mechanisms are in place in your body to make sure that ammonia does not flow freely in the blood, because if it does, as I said, it will cause central nervous system damage. And this is the purpose of urea cycle. It basically is just a way of disposing of ammonia, because we do not want to allow it to flow in the blood as a free entity. So as we get into it, let us begin for the first part of how we dispose of this toxic ammonia, which is a transamination process. So what is a transamination process? A transamination process is basically how we get rid of ammonia from an amino acid, okay? So think of it like this. I'd like to tell you a very short story. I'd like you to think of ammonia as a very, very beautiful prostitute with all the features men want. The breasts, the hips, and the bums. This very beautiful prostitute has got herpes. So it's highly unlikely, in my own opinion, if a man sees a woman as beautiful as shown in this picture, that they will resist her if we say she has herpes. It's very, very, very unlikely. So what I want you to imagine is this prostitute works as an accountant during the day. So this prostitute stays in Chalala near Lusaka Apex Medical University, and she works at East Park. So if we allow our very beautiful prostitute with herpes outside, men will see her, offer her lips, and because she is a prostitute, she might offer sexual services and spread her herpes. Because we do not want her to spread her herpes, what we will do is this. We will put our very, very beautiful prostitute into a car so that no man will see her. And we will have a driver drive our prostitute to East Park. okay? But we will make sure that our driver is a female driver. That way, no man will see her from Chalala to East Park. And in this way, she can keep her herpes to herself and not spread it, okay? So ammonia is our very beautiful prostitute, which is attached to an amino acid. We want to send it away. And a transamination process allows us to send our ammonia away. So how does it do that? So as I said, think of your ammonia, your very beautiful prostitute. I'd like you to think of your car as alpha ketoglutarate. Alpha ketoglutarate is an ammonia transporter. So now a car needs a driver. I'd like you to think of this female driver as the enzyme that will drive this reaction. And this enzyme is a transaminase, okay? And I'd like you to think of this. A car, in as much as it can have a driver, it needs fuel. I'd like you to think of the fuel as the core enzyme, and this core enzyme is pyridoxal phosphate or vitamin B6. So once a transamination occurs, okay, the thing is, this transamination process, what's going to happen is this ammonia will be sent from an amino acid to alpha ketoglutarate. And the keto group on alpha ketoglutarate will be sent to an amino acid to form a keto acid and glutamate. At this point, glutamate can flow freely in the blood, okay, and reach the liver. It is only in the liver where urea cycle can take place. Now, here, the ammonia is going to be dropped off. When we are dropping off this ammonia from glutamate, okay, glutamate will remove the ammonia so that ammonia can enter the urea cycle, all right? And then what happens is glutamate becomes alpha ketoglutarate again so that it can be recycled to be used in another transamination process. So the thing is, what's going to happen here is this dropping off of the ammonia in the liver is what we call oxidative deamination. So oxidative deamination is the removal of ammonia from glutamate to make alpha ketoglutarate to give off free ammonia. The enzyme involved in this reaction is glutamate dehydrogenase, okay? So for this video in particular, I really wanted you guys to understand how we're going to arrive at the urea cycle. So in my next video, I will illustrate a transamination process, the reaction. I will also illustrate oxidative deamination, and then I'll also illustrate urea cycle. In all my videos, I first want you guys to really fully understand why you are learning something, and then I will post another video actually showing the breakdown of the reactions. I really hope this video helped you, and this is going to be part of my urea cycle series. And in the next video is where I will illustrate a transamination process, oxidative deamination, and finally the urea cycle. Until next time, everyone, and let me know if in the comments below if this video helped you, and I really hope we'll be together for a long time. Bye.